Now that we know that, from what we learned on example number 15, or example number 12, we said when f prime of x is equaling to 0, stationary. When f prime of x is equaling to 0, we have what? Stationary points. And then when f prime of x is less than 0, what do we have? We have a function which is going to be what? Decreasing. When f prime of x is greater than 0, what do we have? We have an increasing what? Function. Now that we know that, we're going to use that into our advantage. They say sketch alongside shows the graph of f. Okay? So this is this. Then number A, they say calculate the coordinates of the stationary point. How do I get the stationary point? I can get the stationary point from the derivative, and I make the derivative to be equal to what? To C. And then remember, you will see something here. If you derive a cubic function, check what does it give you. Number A, f prime of x is going to be given as minus 3x squared. Okay? Minus plus 12x and this minus 9. What kind of a function is this one? So a derivative of a cubic function, it's a what? It's a parabolic function. And then remember, now we know how to solve if we put 0 here. Okay? We are getting what we call the x-intercept. So the derivative of a cubic function, we call it with a stationary point. But if we're talking about a parabolic function, if this is a parabolic function, they are not stationary point, but they are what? They are x-intercept. Same person, depending which you are talking according to who. According to a cubic, it is a stationary point. According to a parabolic function, it's not a stationary point, it's the what? Is the x-intercept. So you can put 0 here. If you put 0, you're going to have minus 3x squared plus 12x minus 9. Depending on whether you want to be a hero or you don't want to be a hero, which we usually advise, don't be a hero. That's what we say. So you can use your quadratic formula. If you use your quadratic formula, you can have x, which is going to be minus open bracket 12 plus and a minus root 12 all squared minus 4 multiplied by minus 3 multiplied by minus 9 all over 2 multiplied by minus 3. And then you get your x1. What is your x1? It's 3. What is your x2? It's 1. And then these are your stationary points. In fact, they want the x values of the stationary points. Let's check. They said calculate the, or they want the coordinates of the stationary point. We're not done. As soon as you got these, then, as soon as you get this, you can't take this x and substitute it here because this one is going to give you 0. Agree the gradient, this one. If you have x, you want to get y. Where do you get y, by the way? Yeah, f of x is the only person who can give you y. F prime of x can't give you y. It will never. Even if it wanted to, it can't. It doesn't have that ability. So what are you going to do? You are going to go to f of x and say, I have f of 3, which is going to be equal to minus open bracket 3 cubed plus 6 multiplied by 3 all squared minus 9, 3 plus 3. And what you get? F of 3. You get 3. When x is equal to 3, our y is going to be equal to what? To 3. That's what you're saying. Are you sure? Okay, f of 1. Everywhere we see x, we substitute 1 again. Yeah, both of them, the stationary points. This one stationary point number 1. And what do you call this one? Local maximum or minimum? Leave this one. 3 to 3, yeah. Is the local, this one? Yeah. 3 to 3. Oh, the 3 to 3 is okay. Let's go to this one is the local minimum. It's 1 is 2. 1 is to 1. Yeah. 1 is to minus 1. So you have 1 which goes with what? With -1. So you say this one is the local minimum. This one is the local. So what have you learned, man? You've learned how to determine the coordinates of the turning point of a what? Of a cubic function. What else do they want? They want for which values of x is the function going to be increasing. Start with number 1. Number B, number 1. They want us to talk about increasing. Now look at this thing here. If you talk about increasing, what are you going to have? Look at this. This is number B, number 1. Nah? Increasing. F prime of x should be above the x-axis or below the x-axis? Above the x-axis. What are going to be the x values that are making that to be possible? You are going to go to your derivative. No? If you go to your derivative, you can make it simple, this thing. If you make it simple, you're going to have, okay, minus 3x squared plus 12x, no? Minus 9. Increasing, greater than 0 or less than 0. Have you seen something like this before? What kind of a question is this one? Inequality. Again. Now, we are going to get our critical values, which we already know. We got them from stationary points. No? So our critical values is going to say x is going to be equal to 3 and x is going to be equal to what? To 1. And then as soon as you're done, you are going to draw a rough sketch of this thing. Okay? You have 1 and then you also have what? 3. Our graph, is it sad or smiling? It's sad. It's sad. We want values to be above the x-axis or below the x-axis. Greater than 0, above the x-axis or below the x-axis. Okay, what are the x values that are making this to be possible here? Here they again. What should you say here? Yes, what? Yes. Yes. The sign is going to change. Yeah, it's still going to get the critical values are going to be the same. Your graph is going to be smiling, but when you're going to be looking for values that are above the x-axis. You're going to be having, oh, you're going to be looking for, I think this one is greater than 0. When you're going to be looking for what? For less than 0, which is still this part here. But the critical values are not going to change, remember. So x should be greater than 1, but x should be less than 3. You can come and check it here. Come and check it on the graph here. When is the graph going to be increasing? The graph is increasing from turning point number 1 to turning point number what? Number 2. The other way to do it, I usually do something like this. If I draw a line here, and then it forms a positive angle with the x-axis, it means the gradient. A line is a gradient. If the gradient is forming a positive x-axis with a line, then it means the gradient is positive. If the gradient is positive, it means your graph is increasing. Now they're asking us about decreasing. Obviously, decreasing is going to be the opposite of what? Of increasing. And what are we doing? We're applying what you have learned in grade 11, which was inequalities. Some inequalities, not only do they work there, they are still going to come and work here. Not only are we applying that, we are also using the fact that Elena needs to know how to factorize. Now, on number 2, on number 2, what are you going to have? You still have exactly the same function. You have 1, it goes with what? With 3 again. But here they're asking which minus 3x squared plus 12x minus 9 should be less than 0. I think decreasing is less than 0. So less than 0, you come and check. You are talking about this arm again. And you're also going to talk about this arm, which is an or. It's either you're going in this direction. If you're not going in this direction, you're going in this direction. So how do you write that then? You're going to say x should be less than 1 or x should be greater than what? Than 3. That's what they're going to ask you. Wow. So we are going to do we are going to do activity number. We are going to do activity number 13 and activity number 12.